Hi guys, and welcome to the final part of our Systems of Equations series. And this is going to be the graphing method. I'm going to show you two ways you can do graphing. Now, for the first one, we're going to use Desmos, and then the second one is going to be by hand. So, okay, what is Desmos? Desmos is going to be your math tool on any AP math test that you take, and importantly on the SAT, and I believe as of 2026 it's also on the ACT. But what this helps you with is it helps you solve graphing or systems of equations easier. Okay, so imagine I have this equation right here. So this is going to be your graph. Make sure you click on graphing right there, and then your toolbar should be on the bottom right here. On laptop it's going to look a little different, but it should be easier to type. So we're going to have one equation at the top. We're going to have x plus 2y. Now, on Desmos, you can always use, you don't have to use a y equals equation, but I recommend doing that on graphing calculators such as a TI-84, because it makes it so much easier to handle. So just solve for y and then plug it in. But on Desmos, you don't have to do that. It just solves automatically for you, and as you can see, it plots it on the graph. Now we have our first line. Our second one is going to be 2x and then plus 4y. Hold on, give me a second. And then equals 12. Now, as you see, these are the exact same lines. If I hide blue, you get red. If I hide red, you get blue. And if I move it like there, red goes on top, blue goes on top, as I'm moving the equations layers. So, as you can see, these are the exact same solution. Desmos is pretty simple. If you want to see one where they have exactly one solution, we have 2x and then plus 3y and then equals 11. And then we have 3x minus 3y equals 3. Now, what you're looking for is this gray dot right there, and that is your one solution, and that's your x-coordinate. Your x-coordinate is 2.8, and your y is 1.8. Now, if you want to see no solution, parallel lines, you're going to do 2x and then plus y equals 5, and then 2x plus y equals 1. These parallel lines will never touch, never intersect, nothing, since they're parallel. So, what you have here is no solution at all. And that's basically all Desmos is. It's very useful, especially for systems of equations, and as you get further math, you're going to use it for a lot more. But for this, we're simply focusing on how to plot the graph, and can you find out where the intersection is. Now, we're going to do graphing as the hard way. So we haven't done this one yet. We're going to do x plus y equals 10 and x minus y equals 2. You might recognize this equation from the elimination, or it might be similar, but either way, we're going to solve for y to make it easier. So we're going to have on the top, we're going to have 10 minus x equals y, and on the bottom, we're going to have 2x minus 2 equals y. Now for these ones, I'm going to call the top one y1 and the bottom y2. And it's important to start building these good graphing habits, and then table habits. So we're going to have y1, y2, and then the x. Okay, so we're going to do 0, 1, 2, 3, 4. At least do 5 values in my eyes, so you can get a good grasp of what is the right answer. Okay, so we're going to keep these in mind. So let's do all of y1 first, all of y1. Okay, so we're gonna have 10 minus 0 equals y, and that's gonna leave us with 10. Hold on. And then 10 minus 1 equals 9. And then it goes on, 10 minus 2 equals 8. And then 10 minus 3 equals 7. 10 minus 4 equals 6. Now for our y2, we have x minus 2 equals y. So 0 is going to be negative 2, 1, going to be negative 1, negative 2 is going to be, we're going to have 2 minus 2 equals 0, and that's always going up by 1, so we have 1 and 2. And as you see, we still haven't found the equation yet, so we're still going to go on until it meets up. So we're going to have 5, 6, 7, 8. Okay. 10 minus 2 is, 10 minus 5, 4. 10 minus 6 is 4. 10 minus 7 is 3. 10 minus 8 is 2. Okay. Now we're going to do 5 minus 2 is 3. 6 minus 2 is 4. 7 minus 2 is 5. 8 minus 2 is 6. And we're going to look through the numbers. That doesn't match. Not that. Not that. Not that. Not that. Not that. But if you look right here, the x value is the same, and each y values are the same. So that is where our points intersect, or where our lines intersect. So now what we're going to do is we're going to graph it. Okay? And we're going to go from 0, 1, 2, 8. Okay, we're going to go all the way up to 8. And then we're going to ignore the negatives. That way it's easier. So let's just go from 1 to 10. 6, 7, or 8. Okay. So now let's focus on graphing one at a time. Sorry if this negative is confusing you on these. Let's just start with 2. Let's just go 2 and below. Okay, so our y1 is 2, 8. Okay, so we have 2 and then 8. Now we have 3 and then 7. Then we have 4, 6. 5, 5. And then we have 6, 4. 7, 3. And then 8, 2. And then that roughly gives us this line. It's not the best line. Hold on, I can make this 6 a little better. Like that. Now if we do the right side, we're going to have 2, 0. Wait, let me do that better. That was not a good, that was the wrong spot. 3, 1. 4, 2. 3, 5, 3. 4, and then we have 6, 4. And then we have 7, 5. And then 8, 6. And then we get a rough line right there. Hold on. As you see, it intersects there. This is by no means a good graph. It's hard on these ones because you know, like the actual like grids, but it does give you a rough estimate. Your teacher is probably gonna expect a better graph than this, but they'll give you graphing paper. But the main point is to take it point by point, solve it out, make sure you get the right value, and you can just stop once you get the same. Each y1 and y2 have the same x value right here. As you can see for 6, both of them give you 4. on the graph. They'll meet like that. So that's going to be all for the graphing video. I hope you've learned a lot. Stay curious. Remember to embrace curiosity.